So today we're gonna work on this worksheet number 8 about partial fraction decompositions. So we have two questions here. The first question is to set up the partial fraction decomposition, but we don't have to evaluate the actual coefficients. And for the second question, we need to work out the integrals. So now let's start with the first one here. For decomposing a fraction into partial fraction decompositions, we have two things to pay attention to. The first thing is to make sure that the power of the numerator is less than the power of the denominator, right? That's the first thing. And the second thing is to make sure that the factor inside your denominators are irreducible. Otherwise, we would need to do some arrangement before we approach the partial fraction decomposition. So now let's check them out. Firstly, check the power. The power on the top is this square, right? Which is less than the total power in the denominator, right? That is obvious. So that's the first thing. And the second thing, I check the factor, each of the factors in the denominator. I'll make sure that they're irreducible. This one is irreducible, right? And this one is also irreducible because you can check the discriminant delta, right? If delta is less than 0, then it's irreducible. However, this one is not irreducible, right? We can reduce this one. This one, x squared plus 3x minus 10, can be reduced to x plus 5 times x minus 2, right? So we're writing that we have 3x squared minus 4x plus 5 over this x minus 2, right, times that x minus 2 squared, so it becomes x minus 2 to the 3, and x plus 5 here to the 2, right, times this one. Now we're ready to do our decomposition. So it is equal to, firstly, for the first factor here, this factor, right? It has the power 3, right? So we're gonna let this equal to a1x minus 2 plus a2 x minus 2 squared plus a3 x minus 2 to the 3, right? That's for the first term there. And the second term, we have this x plus 5, right? X plus 5. So we're gonna plus a4 x plus 5, right? And plus a5 x plus 5 squared, right? So that is the second term. And for the third term here, this irreducible polynomial is of degree 2. So we're gonna have degree 1 polynomial a6x plus a7 in our numerator, and underneath that is this one. Okay, so that is how we set up the decomposition, and we don't have to evaluate the actual AIs here. So we're done for the first questions. Okay. Just keep in mind that we have two things to check before we do the factorizations, do the decompositions. So now that is our question A. And moving on to the question B here. Do the same thing, right? Check the power. The power on the top is less than the power in the bottom. Right, so this first condition is satisfied. Secondly, we're going to check each factor, make sure that they're irreducible. This one is not irreducible because you can factor out the x squared. And the second one here is not irreducible because it's a perfect square, right? As for x, so let me write them down here. So this is equal to 8 divided by, for the first term here, you can factor out x squared, and you will left with 2x plus 7, okay? And for the second term here, it's a perfect square, so it's 2x squared plus 1 bracket square. Okay. Now, after making these changes, we're ready to set up the decomposition. Right. For the first factor here, the first factor, this one here, right, we're gonna have a1 divided by x plus a2 divided by x squared. And for the second term here, this term, we're gonna have a3 divided by 2x plus 7, okay? And for our third term, the third term here, this term, it's a degree 2 polynomials. So we're gonna have degree 1 polynomial in our numerator. So we have a4x plus a5 divided by 2x squared plus 1, right? And because it has a square, so we need to continue a6x plus a7, right? Continue. And this denominator becomes the square of the previous denominator. And that is how we set up the decomposition. Very straightforward, right? Check two things and then do the following decomposition. Okay, so that is our first question. And now we will move on to the second one, evaluate the integral. So before we do the integral, I want to remind you of two integrals that will be frequently used in the following questions. The first one is this 1 over x squared plus a dx, or maybe plus r, right? We're very familiar with this one, right? You can factor out the r here, so you have x squared divided by r plus 1 dx, right? And then you put that r into the square, so this becomes x divided by square root of r, right? The square plus 1, something like this, right? Dx. And you also decompose this r into square root of r times r, right? And then you put one of the square root into the differential sign here. So here it becomes x divided by square root of r. So do something like this, right? Now this becomes this times tangent inverse of x square root of r, right? Plus c, of course. Well, plus c is not important. What I want to indicate here is that you will come across with something like this very, very often, okay? And also, there's another thing, that is 2x divided by something like x squared plus let's say plus r dx, something like this. Right? When you have x on the top, you can put that into the differential sign. So you have 1 over x squared plus r dx squared, right? And this will become ln of x squared plus r. Right? Of course, we have the plus c stuff, but that's not important. What I want to say here is you will come across with this kind of integrals very often, because we're having the degree 2 polynomial in our bottom, in the denominator, and our numerator is either a constant or a degree 1 polynomial. So we have these situations very often. So now, after knowing this, okay, let's move on to the first question, question A. Okay, we need to handle this expression first. x3 minus 2 divided by x2 minus 4, right? Check the power, right? And the power on the top is greater than the power in the bottom, so it's not good. So we can reduce it. x3 minus 4x, right? And then plus 4x minus 2. And then split the fraction. So we have x plus 4x minus 2, x squared plus minus 4. Okay, like that. And then this is better now. And then we see that the power on the top has been decreased. However, the factor in our denominator is not irreducible. So we need to do something further to reduce it. Reduce it, x minus 2, x plus 2. Okay, so now this is the thing that we need to work on. Okay, this thing. This 4x minus 2 divided by x minus 2, x plus 2. We're going to set the partial fraction like a1, just a over this x minus 2 plus b. Oh, why is this one here? Move it back. Plus b x plus 2, right? Something like this. And you're going to multiply through, right? Multiply through the denominator, and you have 4x minus 2 equal to a times x plus 2 plus b times x minus 2. And for convenience, I will skip the computation here because it's very simple. You can plug into values of x to figure out the a and b. That is done in the Math 1300, suppose. So you can let's say, let x equal to 2 and negative 2, right? With respectively. And you have a equal to 3 over 2 and b equal to 5 over 2. So now your integration has become, now this thing has become x, right, plus this 3 over 2 times 1 over x minus 2 and plus 5 over 2 times this x plus 2 altogether dx. Okay, very simple stuff, right? And then the final answer becomes 1 over 2x squared plus 3 over 2 ln x minus 2 plus 5 over 2 ln x plus 2, and that's all, plus c. C is any real numbers. Okay, very simple, right? A lot simpler than the first question, right? But we need to actually compute what those coefficients are. Maybe that takes a bit of time, but the idea is very intuitive. So we can now move on to the second question. Second question here, okay? this guy. Same steps, we work on this fraction, right? See that this fraction, the power here on the top is less than the one in the bottom, so it's good. And also, we see that the factors in the bottom they are both irreducible, so we're ready for the decomposition right now. 5 minus 3x divided by this, set this equal to a1 over the first factor, maybe just a, that is x plus 1, okay, and plus the second factor, x squared plus 3, because it's of degree 2, so our numerator is gonna have two terms, bx plus c, right? And then also multiply this through 5 minus 3x equal to a times x squared plus 3 plus bx plus c x plus 1, okay? And you can, let x equal to 3 numbers and then figure out what those a, b, c are here. And for convenience, I will skip this computation. Just tell you that the a is equal to, what is a? Let me look at the answer. A is equal to 2, right? B is equal to negative 2, and C is equal to negative 1. Okay. And now we can change this into A that is 2 divided by x plus 1, right? Plus B negative 2x, C is negative 1 divided by x squared plus 3, okay, dx. And we're gonna split them. Okay, so this becomes negative 2x x squared plus 3 and plus negative 1 x squared plus 3 dx. Okay. Now we do the integration for the first term, that is obviously 2 times ln x plus 1, right? And for the second term, okay, this one here, well, keep in mind that we have talked about the integral at the beginning, that is this integral, the second integral here, right? The second integral here. You have x term on the top and the bottom is something power plus something, right? So this one is also x squared plus r, right? So remember this, okay? We have the steps here. It's just the same, exact same integral. So this becomes the negative. Let me see. Negative 1 times. Maybe just change the sign here. Negative ln x squared plus 3, right? Okay, and the last term, this term here, right? That is our first type of integral that we've talked about here, right? Have the constant on the top and square plus something in the bottom, right? That is this guy here. Okay? 1 over square root of r tangent inverse x divided by this. Okay, exact same step. So I'm going to write that directly. So this is going to equal to, this is the green guy here, and the orange guy, that is minus, okay, minus 1 over square root of 3 tangent inverse x divided by square root of 3. Okay, this one. Of course, we need a plus c, right? That's the cliche, a routine that we need to do. Okay, so that is our second question. Very straightforward, very simple, right? Partial decomposition, and then go through the intervals, the integrals. So now we're ready to move on to the third question, question C here. Okay. Question C. Okay. And we're gonna do the same thing. Kind of observe this fraction, right? Check the power. The power on the top is less than the power in the bottom. That is very good. And also we are gonna check the discriminant. Make sure that the polynomial here in the bottom is irreducible, because it can be actually written as a perfect square plus something. So this is 3x plus 1 square, right? Plus 1. Or plus 4, I should say. Right? If you open the bracket, you see that they're equal. So because of that, it's a perfect square plus something. So its discriminant is less than 0, right? It's irreducible. So we don't have to do anything here, and we can just work on the decomposition. But also we notice that the denominator here is already of degree 2, and the numerator is of degree 1. So there's also nothing much for the decomposition to do, right? We can just work them out directly. And now we see that this guy is very interesting. There's something square, so we want it to be u, right? Let's see. Observation here tells us. So we let this u equal to 3x plus 1, right? So that the du is going to be 1 over 3 dx, right? And we have dx equal to 1 over 3 du. And also this 6x minus 1 can be written as 2u minus 3. Okay. And we can now compute this directly. 2u minus 3 divided by this u squared plus 4, right? And the dx here is replaced by 1 over 3 du. Okay. Okay, so now we have this guy here. This guy here. That is 4. And we're gonna split them into two terms. U squared plus 4 minus 3 u squared plus 4 du. And also handle the coefficient here. That 1 over 3, that 3 cancel with this, so this becomes 1, right? And another 1 over 3 comes here. So here becomes the 3 over 2. So let me change this term here. Three over 2. Okay, like that. This thing, du. Okay, and I'm gonna write, okay, so maybe write the 2 inside. Okay, so this looks very familiar, right? The first term here is the first type, the second type of integral we've talked about, and this is the second type of integral, or maybe the first type, I'm not so sure. Let me look up this. Okay, so that is the first type here, and the second type, right? So we can just follow this to figure them out directly, just like what we did for the previous question. So now I'm going to write directly. This green one here, it's 1 over 3 ln, not this green, 1 over 3 ln u squared plus 4, right? And also we have the second one here, that is minus 1 over square root of 4, right? That is times tangent inverse. I guess I'm using the wrong color. I'm talking about the orange term. So that is 1 over square root of 4 tangent inverse of this u divided by square root of 4, right? It's this guy. Of course, we need a plus c. That's the cliche. Okay. And we're going to finally change the expression u into x. So the final answer becomes 3x plus 1 squared plus 4, right? Minus 1 over 2 tangent inverse. This u divided by square root of 4, that's 3x plus 1 divided by 2 plus c. C is in R, right? So nothing very complicated here, right? It's the exact same thing. We even don't have to do the decomposition. But we do need to realize why we don't need to. Because this is degree 1 polynomial, this is degree 2, right? It's good enough. And we also need to know this this substitution, right? That is also intuitive, right? Letting u equal to this. So that is our question C. We see that it's not always doing the decomposition. It's always depending on the situation, right? So now move on to question 4. Okay. Question 4 here we have this cube root that is ugly, and we're gonna, change that. So we'll let this u equal to this ugly stuff, and we're gonna make it equal to the cube, and we're gonna find dx, right? Dx is equal to 3u squared du, okay? And now do the replacement. That is u plus 1 times, this is u3 minus 8, and dx is replaced with 3u squared du, okay? And now we're going to continue. We have this 3u3 plus 3u2 divided by u3 minus 8 du, okay? Looks like a fraction. So we're going to go through those process to do the decomposition. Now check the power on the top, right? It's equal to the power in the bottom, so that's not good. Something wrong with the power. We're going to reduce the power. So reduce the power, we have this. I'll maybe write it here. Reduce the power. 3u3 plus 3u2 divided by u3 minus 8 can be written as 3u3 minus 3 times 8 plus 3 times 8 plus 3u2. And we're going to split this fraction into 2. So we have 3 here plus this 3u2 plus 24 divided by this minus 8. Okay, now we check the power again. The power has been reduced, so it's good to go. But the factor is not yet irreducible, so we're gonna use the difference of cube formula. here to reduce it. A minus b, a squared plus ab plus b squared, right? Because this guy here is 2 cubed, okay? So that changes to 3 plus 3u plus 24 divided by u minus 2, u squared plus 2u plus 4. Okay? And obviously, this is irreducible because it's a perfect square plus 3. Right? Irreducible, this one here. So now we can start the decomposition from here for this guy. Okay? Decomposition, 3u squared plus 24 divided by this is going to be decomposed into the first term first, this one, right? 1 over a over this. Okay. And then we're going to do the second one, u squared plus 2u plus 4, right? And because it's of degree 2, so we have bx plus c, the degree 1 term on top of that. And we're going to multiply through, right? Multiply through 3u squared plus 24 is going to be equal to a times u squared plus 2u plus 4 plus this bx plus c times u minus 2, right? And you're going to plug in whatever you need. Plug in maybe u equal to 2, right? Something like that. That's cliche, and we can skip. So we have finally a is equal to 1, b is equal to 0, and c, what is c? Is equal to negative 2. Negative 2. Okay? And knowing that, we can plug in, go back to the previous integral. So the previous integral now can be written as 3 plus, right? That orange guy has become 1 over u minus 2 plus this negative 2 divided by this u squared plus 2u plus 4 du. Okay? Like that. And now, let me see if I'm missing anything. Okay, so continue. We have this equal to 3u for the first term, right? The second term, that is ln u minus 2. And the last term, this term here, we're going to notice that this thing can be changed to u plus 1 squared plus 3, right? So we can write that one more step. So plus this negative 2 u plus 1 squared plus 3 du. Okay, du. And since du is same as du plus 1, right? So we have this guy here. But this guy is the second type of integral we've seen at the beginning. That is this one. Okay. And this one here. This one. It's just with the u plus 1 in the bottom as the replacement of x, but that's not a big deal, right? So we can write this out directly as equal to 3u plus ln u minus 2, right? plus this. It's gonna be negative 2 divided by square root of 3, okay, times tangent inverse u plus 1 divided by square root of 3, right, plus c. Okay, the same type of, exact same type of integral here. But finally, we're gonna replace this back, right? So replacing everything back, we have 3 cube root of x plus this ln, 3ln, 3 cube root minus 2, right, minus 2 divided by 3, then multiply with another 3, that is 2 square root of 3 tangent, this u plus 1 is going to be this plus 1 divided by square root of 3 plus c, where c is any real number. Okay, and let me just check here. It seems that did I lose the coefficient here? Okay, actually I lose the coefficient here. The coefficient here is, there's a 3 here, so this one, I forgot to factor out the 3. So this is actually, it's a 3 here. Multiply with every single term. Or you can think of like, there's a 3 here. So what I'm factoring out is actually the u squared plus 8, not the 3u squared plus 24. It's this one, okay. So there's a 3 here, right? There's 3 here. Just fixing the coefficient, right? So it's 3 here, 3 here. Okay, so that now it makes sense to put that 3 back, and that is our final answer. Okay, so that is our question D. Okay, question D, like that. And now we have our question E left. So question E. Question E here, lots of trig functions, cosine and sine, right? So we're gonna make them in terms of just one single trig function. Obviously, we're gonna do something to this cos, right? Cos 3 here. Cos 3 here is gonna be split into cos square x and cos x. And we're gonna put this cos x into the differential sign so that it becomes sine of x. And for the other cos square x here, we're gonna use it and write it as 1 minus sine square x as the replacement. So that now we have 2 times 1 minus sine square x, right? Divided by this 2 sine square of x minus 7 sine x plus 3 d of sine x. Okay, so now it makes sense to do the replacement x equal to u equal to sine of x. Okay, replace everything with u. So this is 1 minus u squared divided by 2u squared minus 7u plus 3. So back into our previous expression, polynomial expression. Okay, so we're gonna do decomposition. By the way, open this bracket, this 2 minus 2u squared. Open this bracket. So we firstly check the power. The power on the top is 2, which is equal to the power in the bottom. That is not good. So we're gonna decrease the power. So 2 minus 2u squared. 2u squared minus 7u plus 3, right? Can be written as, let me see, written as negative 1, maybe negative of 2u squared minus 7u plus 3, and minus 7u plus 5, like that. This treatment, right? It's gonna help us reduce the power. So it can be written as this fraction. Okay. And after that, check the power on the top has been reduced, right? And then we need to make sure this is irreducible, right? Is it irreducible? No. We can factor this out, right? This guy can be factored as 2u minus 1 and u minus 3. Okay. And after this, I am able to do the decomposition. Okay, so decomposition here. Negative 7u plus 5 divided by 2u minus 1, u minus 3. If you're wondering how I can figure out this decomposition, I just tell you by the way here. 2u squared minus 7u plus 3, right? And we're gonna factor the leading term into two things, maybe 2u and u, right? And do this cross multiply. And negative 1 here and negative 3 here. When you cross multiply, you get negative 6u for this line and negative 1u for this. So it's totally negative 7u, which matches the middle term here. So that's how we came up with this factorization. So this is going to be set to equal to the first term, the first factor, a over this, and the second factor, that is u minus 3, that is our b, okay? And then just skip this computation, you know how to compute it, so several computation here. And we get that a is equal to negative 3 over 5, and b is equal to negative 16 over 5. Okay, just multiply this through like what I did before, and then plug in u equal to maybe 2 and 4, right? Plug in whatever number you like to figure out what the constant a, b are here. So after that, I am able to now write the integral. This integral now becomes negative 3 over 5 times 1 over 2u minus 1 plus the other one, that is negative 16 over 5 times u minus 3 du. Okay, that's one du. And that, and also I almost forgot this negative 1. This is small guy here. Okay, negative 1. Okay, negative 1. Almost forgot that negative 1 here. Okay, so adding it back. So I can do the integration. This is going to be negative u, okay, for the first term. And the second term is going to be negative 3 over 5 ln of 2u minus 1. Okay, and the last term is going to be negative 16 over 5 ln u minus 3. And the thing plus c, always here. Okay, so we have our integral here. And now we need to replace this back. Oh, sorry, I also forgot a coefficient here. The coefficient is 2u here. Okay, so 2u here. This guy is gonna generate a 1 over 2 at the beginning. Okay, just to fix that coefficient. So now I can plug in my expression, u equal to sine of x, right? So everything can be written in terms of x, minus 3 over 10 ln this 2 times sine of x minus 1 minus 16 over 5 ln sine of x minus 3 and plus c, where c is any constant. Okay, so that is this question. I think yeah, I have included everything here. Firstly, the trig function treatment, and then decomposition, and finally get the integrals. Okay, so we now see that these 5 questions are exactly the same, right? Go through the exact same process, nothing too much complicated. So I want to see if you guys have any questions. Any questions?